All right, I've got my mouser order, my first mouser order for the Toshiba 3100E upgrade. So what I'm doing is I am replacing every single cap on the power supply. And what I'm also doing at the same time is replacing them with better quality caps, and in places where it makes sense, putting larger caps into the power supply. For example, the main power supply caps are going to get quite a bit bigger in value. Some of the output caps are going to get bigger in value, and that just makes the power supply happier. Probably won't do anything really for anything else, but it'll make me happier. And what I've also done is I'm replacing everything I can with monolithic ceramic or film, because these are immortal. These just really don't fail at all like electrolytics. In areas where I am putting electrolytics in or putting them back in, I'm using the extreme high temp reliability caps. So the idea is to make this power supply last at least another 30 years. So that's the plan. I have found this cute little on the CPU, at least on this one in the CPU, it didn't have any heatsink on its clamp. So what I'm going to do is I found a cool little solution, a little tiny heatsink, and then I'm going to use a little tiny fan. So that'll be kind of fun. Of course, the fan eventually will fail given time, but it's okay because it would work fine without any of that. So that's all right. Speaking of fans, I am replacing the fans in the unit. I'm using some kind of expensive but high quality Delta fans for this. These are drop-in replacements. They're quiet, but that's not the main point. The main point is they're more airflow than the fans that were in it. So that's going to produce a cooler overall computer and a cooler power supply. Most of this power supply, actually, power-wise, is used up by the plasma, by the 200 volt output. So I'm going to be focusing on that 200 volt output to make it cleaner and do some stuff to all that to make the plasma display better. So anyway, there we have it. So now I get around to doing soldering. But the idea is I'm trying to make the best 3100E. In previous videos, what I've already talked about was I'm going to replace the CPU chip with a 16 megahertz version, even though it's only, it's not going to clock faster. It gives it a little more headroom, so maybe that'll make it a little bit better. I've thought that I could replace the clock. It's a 24 megahertz oscillator, which is, halved into 12 megahertz. In theory, I could make this a 32 megahertz oscillator and overclock it, but then of course you get into the problems of, is everything else going to handle that, the overclocking, the RAM and the, just everything, all the peripheral chips, everything else. So I don't know what I'm going to do with that yet. That'll be later, but I might do that. At least try it. I could certainly overclock it some. I can overclock it some. I've got a 287XL mass coprocessor coming. I'm also there's a few caps on the boards here. I'm going to replace those with monolithic ceramics. I've already recapped and done a bunch of engineering work on the plasma display itself. There's no doubt I can improve the performance of the display. I already have. I've got before and after pictures of the pixels. There's a lot of noise on that 200 volt rail as it does the scanning, and that noise shows up as the background, the off pixel illumination. And so if you eliminate a bunch of that noise, then what you get is that you get a darker background, and you don't get the pixel adjacent to the lit pixel to be as illuminated. So that's all really encouraging. That plus the power supply changes should make for just an awesome looking plasma. So that's all fun. Anyway, all right. So back to work. Some of the other things, I'm obviously working on, figuring out how to have a much larger drive. There's a bunch of options in that whole respect, and I'll go down one of those paths to figure that out. I want to leave my ISA card slot open because I want to drop in maybe a SCSI card, or a GPIB card. I'm not sure exactly what I want to do, so I don't want to use any of those options. I don't want to occupy that slot with just a hard drive. I have other plans for that slot, so I want to try to figure out what I'm going to do around all that. I was thinking maybe, I don't know enough about it, but maybe it's possible to, the BIOS I assume is in the EEPROMs, that the microcode in here, maybe it's possible to just simply change the numbers, for the drive types, and maybe that could address more. So maybe a little hack to the EEPROMs, to the BIOS, might be enough to, address more of, to get a larger hard drives in here. Anyway, eventually I'll get around to the RAM, and that's a kind of weird problem. I'd like to really find somebody who could just do the RAM for me. That'd be the best solution. But anyway, so I am progressing along onto an evening of soldering. While most of the recapping on a T3100E is straightforward, what's really going to be challenging is there are caps way down in there. And this copper heatsink is soldered in 4 places on each side. You can see the cap there. That one I can probably get to. I'm going to try to use needle nose and try to get in there and get those. These are high voltage output caps for this whole supply really over here is for the plasma. So this is all really important, but really, really challenging to get to. So just be aware. If you decide you're going to recap one of these, it's going to be work. Unsoldering that whole copper heatsink would be really annoying. Plus I got to get it off, which I got to take the transistors off. And of course that one transistor is behind a cap. 2 of them really are behind a cap, so that would be annoying all by itself. So I'm going to attempt needle nose and get them out and put the other ones in there that way. We'll see. Okay, so in doing the Toshiba 3100 power supply, getting to this whole part of the board to recap it, the best way, because all the caps are buried under a multi-layer of heat sinks, the best way to do that is to unsolder and pull out the whole assemblies. That is way easier. Also, when doing that, I noticed, well, I'm sure we can't see it on the video, yeah, but I noticed that there are some solder rings on some of these parts that get hot, and of course that over time will result in faulty connections. So it looks as though I'm also going to be resoldering every joint on the board just to be sure it's okay. So anyway, so now I'm not saying any of this work is easy. I've got a tremendous amount of experience in soldering and doing this type of work. So, don't try this at home unless you really know what you're doing. Anyway, but yeah, that is the best way to do it. Just pull them all off as modules and then recap, which I have not recapped yet, but there's a lot of caps in here that are all just directly underneath all the hot power supplies, which I'm sure are all dried out. So all of those electrolytics gotta go. So on the Toshiba 3100E power supply restoration, since I had to pull off the heat sinks anyway in order to get to the caps, I decided to go ahead and replace the thermal paste with something more modern because the stuff today is better. Plus, it can't hurt. The thermal paste has been on there a while. It could be a problem. So I decided to go ahead and do that on all of the power devices. I've also completely resoldered the board, every connection, and when I did that, as I went, I clearly noticed the rings in the solder around parts that get hot and cool off. That is a sure sign that it is going to fail. Those solder joints are going to fail. So So there's no doubt that that to get a really good restoration on this, it's going to require resoldering all the solder points, which is actually really easy to do. So not the end of the world. I'm using a Kester 2% silver solder to make sure that all that is super happy. Anyway, so this is working out fairly well. It wasn't that much work to do it. The parts were kind of expensive because I used a lot of monolithic ceramic caps rather than electrolytics where the values permitted. On the larger caps, though, you can't do anything else really with the larger caps but electrolytics. What I did there was that I used larger values where it made sense, like the primary caps. Instead of 200, they're now 330 microfarad. And I also used some extremely long life, high temperature caps. So those should last another 30 years. And the larger values is good, not only for performance now, but also over time. As these dry out in, say, 40 years, they'll still have some juice left in them, to still get to that 200 microfarad level. So these could still be good for quite a while. The other caps, like this is the 5-volt power supply rail filter caps. I put much larger caps in here. They were 1200, they're now 3900 microfarads. That just makes for a much cleaner, much happier 5-volt supply. Where I could, I used monolithic ceramics rather than using electrolytics, and that's important. I've increased the capacitor for the 200-volt filter cap. I'm not sure if I can get I'm not sure I can get it all back together because it's all really close. It's within a few millimeters of, I might have some problem here. So I'm going to look at that. But I increased this cap quite a bit. I forgot, but I've radically increased this. That's going to better filter the juice, the 200 volts going up to the plasma. So that's a good thing. Anyway, so every single cap on this entire assembly has been replaced. Almost all of them with monolithic ceramics. I don't think you can really see down in there, but all of the electrolytics that were used in those areas have all been replaced with monolithic ceramics. So this should last essentially almost forever. So there we have it. Okay, so I've now completed the project. This is after all the resoldering, all the caps and everything were done from it. It's in really good shape now, so hopefully this will be good for another 40 years is the plan. All right, so post-mortem, after replacing every electrolytic cap in a T3100E Toshiba gas plasma. Most of this is out of the power supply. There's not a lot of electrolytics outside of that. There's some on the back side of the plasma display. Going through and testing all these, but I used just a basic meter to test them rather than a good capacitor tester. None of them stood out as particularly bad. A little funky here and there. Some you could see leakage on the bottom though, even though they tested okay. So not bad. I mean, they used quality caps at the time, and it shows, but every single cap here must have issues. That many years and electrolytics decay. That's just physics. So anyway, I feel much better that they're all replaced. I'm going to do this same thing on my real 3100E, but this was just getting a feel for everything. So, but yeah, it's all happy and working great now. So, but anyway, yeah, that's a postmortem. I would replacing all of it. It's quite a bit of work. I do this a lot. And that power supply was a little challenging to do. You had to take out 2 power supplies with all the transistors on it to get to all the caps. I replaced all of the values of cap that I could with MLCCs, with multi-layer ceramics, so that they won't decay in the future. And I made the main power supply, the main high voltage caps coming into it bigger, 380 versus the 200, and I made the high voltage output cap rather than I forgot what it was, but I made it a lot more. So to smooth out the 200 volts for the display, make it happier. So anyway, my floppy drive is toast, pretty much. It will work, sort of, kind of, but it had some caps completely. It had one cap completely blow out on one of its boards, and ooze stuff all over everything. And I did my best to clean it, but it got better, but it's still toast. So I'm getting another unit to take care of that. But anyway, so all is well, and on to the next steps. Okay, so power supply is back in place after all the recapping and mods. Everything is happy. The CMOS battery seemed weak, but even replacing it didn't really fix the problem. But this is a parts board, so that's okay. There could be something actually wrong with its CMOS RAM. I'm not sure. But I can do setup on it and set it, and it'll work fine. So for my testing, it's great. So this unit is to give me experience, so that when I get to my real unit next, after I'm done with all of this, then I'll know exactly what I'm doing. All is well. You can't really tell from the video, but the mods that I did improve the quality of the display. The bars rolling through it are just the iPad video stuff that those aren't in real life. You can't, like I said, you can't really tell, but there's definitely been improvement in the quality of the display. So that was encouraging. That had to do with, really addressing the 200 volt display, the power supply rail, and also doing some mods to the display itself to make that all happier. So little tiny bits, not a lot, but what I do know is that the display is immortal as far as caps go, and the power supply is now immortal as far as caps go. This main board is immortal, as I replaced all the electrolytics on that with monolithic ceramics. I put 2 Delta fans in, and those are actually, they have more airflow, but they're less noisy. So that's worked out really well. So that's keeping the entire power supply literally cold. So that's good. I still have some other things to do, besides all the, hard disks and getting all that happy and the RAM. I need to put on the CPU, what I need to do is I've just got a heatsink stuck to it temporarily. I'm going to put a real heatsink on it, and I've got this itsy bitsy tiny fan that I'm going to also put on there. So I'm going to cool that off quite a bit. I've got a 287XL coming. I'm going to put that in eventually. I'm going to put some RAM in. But this unit is my experimentation unit. So I've gotten this pretty much up to where I need it to be, because I can now use it to do additional work. So the additional stuff is going to be, I've got to figure out what I'm going to do. Well, the floppy on this one was just toast. Some caps had leaked on the board, and I tried to clean it, but it's still acting completely wacky. So that's messed up. But I have a good unit that everything does work. It has almost no hours on it. So I know I'll have good floppy there. I also have a third unit coming. It has a bad display and a bunch of things wrong with it, but it has good floppies in it, and so I'm going to cannibalize that one and get some stuff out of all that one. So all is well so far with the restore project.